Hey everyone, how are you? In this video, we are going to solve the lead code problem of the day, and the problem is minimum operations to make the integer 0. First of all, let me explain you the problem and then we are going to solve it. So in this problem, we are given two inputs and the inputs are num1 and num2, both are integers. Our target in this particular problem is to make the num1 which is given in the input as 0, and for that we can perform some operations. But our target is to perform the minimum number of operations, and we have to return how many operations we need to perform to make this num1 equal to 0, and this number should be as minimum as possible. So basically we need to return the minimum number of operations required to make num1 as 0. Now what is that operation which we can perform? Every time we perform an operation, we have to say that this num1 will be equal to the current value of num1 minus 2 to the power I plus num2. Now this num2 is given in the input and this I has a range. It will be within the range of 0 to 60. So basically you have to perform this particular operation, and every time you perform an operation, your target will be to make the num1 equal to 0. For example, if the given value of num1 is 22 and the value of num2 is 5, in this case the output is going to be 2. It means we have to perform two operations. We have to perform the operations two times to make the num1 equal to 0. The operation is simple: num1 minus 2 to the power I plus num2. You will every time subtract this particular value from num1 to make it as close as 0, and ultimately should be equal to 0. Now the output in this particular example is 2, and the reason is we can say 22 minus 2 to the power 3 plus 5. Now this 3 is the I am talking about in the formula. The formula is num of 1 minus 2 to the power I plus num of 2. So this is num of 1 minus 2 to the power I is equal to 3 here, plus num 2. So I can say 22 minus 2 to the power 3 will be 8 plus 5 will be 13. 8 plus 5 will be 13. So we can say if you perform the operation one time, you can say 22 minus 2 to the power 3 plus 5. This will be 22 minus 13. The remaining value of num1 is 9. We have to make it equal to 0. So we perform the operation one time, but still the value is not 0. So we can say 9, the new value of num1 minus 2 to the power 2. This time we have kept the value of I equal to 2. Basically the value of I can be within the range of 0 to 60. Now I can say 9 minus 2 to the power 2 will be 4 plus 5, because the formula is simple. Every time you perform an operation, it is going to be 2 to the power I plus num of 2. So 2 to the power 2 plus 5. Now this value is equal to 9. So I can say 9 minus 9, it will be 0. So ultimately we have made this value of num1 equal to 0, and we have to perform total 1 and 2. Two number of operations. So the output is 2. Now the thing is, guys, we have to minimize the number of operations, and you might say that instead of using the value as 3, why can't we use a higher value so that we get to subtract a bigger value and make it 0 as soon as possible, right? Let us try this. If I say that 22, that is num of 1, num1 minus 2 to the power 4. Let's keep the value of I equal to 4 plus 5, then this will be 16, then 5, this will be 21, right? So I can say 22 minus 21, this will be equal to 1. So after performing one operation, now the remaining value is 1, right? Still we are remaining with one value. Now you can say instead of I equal to 4, let's make it 5. Alright, num of 1 which is equal to 22 minus 2 to the power 5 plus 5. This is num2, right? This is 32 plus 5, this is 37. So we have to say 22 minus 37, this will be minus 15. Once it is negative, you cannot make it positive. You can make it positive, but since the value of num2 is positive itself, if our num1 is minus 15, it is negative, you have to turn it to 0. You cannot turn it to 0, right? Because now you have to say minus 2 to the power something. This is going to be positive. This is going to be positive since this is positive. So if you say minus 15 minus any positive value, this will never be equal to 0, or will never go towards 0, right? It will just keep going negative. So that is why we cannot just choose any higher value and just make it 0 instantly. So we have to be a little bit smart here. And let me tell you what we can do. We can just use mathematics, and I will tell you how. The question says one more thing. Let me tell you that if you cannot make the value of num1 equal to 0 by performing this operation, you will have to return minus 1. For example, if the value is 5, that is num1, and the value of num2 is 2. In this case, you cannot turn this 5, the num1, to 0, and I will tell you how. If the num1 is 5, you can say num1 minus 2 to the power 1 plus 2. That's the num2. Num2 is 2. So this value will be equal to 4. We have to say 5 minus 4, this is 1. Now you cannot say that this is 1 and now minus 2 to the power, let's say 0 plus 2. This value will be equal to 3. So we have to say 1 minus 3, and this will become negative, and once it is negative, we are never coming back to positive. So we cannot perform any number of operations and make this num1 equal to 0, because once we start decreasing some numbers from this 5 minus some particular amount, if you take this value as 2, this will be negative. If you take this value as 1, this will be 1, then again this will go negative once you perform more operations. So the simple thing is, we have to ensure that this can be equal to 0, and if it is not equal to 0, if it cannot turn to 0, we have to return -1. And now let me explain you how we can solve it. You are just using pure mathematics. Let us say we have an answer. Let us say we can solve it. So we can solve it, let us say, in k times. Let us say we are performing k minimum number of operations to turn our num1 into 0. That's what we need to do. Now if you perform the operation k times, then every time what you will do is you will say the current value of num1 minus 2 to the power a. Now this a, I have replaced the I with a, and this a will have a range of 0 to 60, just like I. So we can say num of 1 minus 2 to the power a plus num of 2. Now when you perform the operation 1 times, this is the new value of num1, right? Now with the new value of num1, if I say minus 2 to the power b plus num of 2, basically this is the new value of num1, and now we are saying minus 2 to the power b. Again this b is replacing I, and it has a range of 0 to 60. So with the new value of num1, we are again performing the same operation. So it's like saying that if I perform the operation k times, then I am saying the new value will be equal to num of 1 minus 2 to the power a plus num2 minus 2 to the power b plus num2 up to 2 to the power k plus num2, right? Basically if you perform the operation k times. Now let us focus on this formula. We can say that let's group the 2 to the power a, 2 to the power b, dot dot dot, whatever 2 to the power numbers we have together, and let us group the num2 together from every operation. So now the new formula will look like num of 1 minus 2 to the power a plus 2 to the power b k times minus k multiplied by num of 2. Basically this is equal to num of 2 plus num of 2 k times, right? K times. So this is like k multiplied by num of 2. And we have to ensure that this value becomes 0, right? If this value is equal to 0, we could simply take this particular part in the right hand side, and now we can say that our formula is num of 1 minus k multiplied by num of 2. This particular part will be equal to this particular part, which is 2 to the power a, 2 to the power b, sum of 2 to the power a plus 2 to the power b k times. So this particular data should be equal to the sum of powers of 2, right? And we have to minimize the value of k. Now try to think about this. This k is the number of operations we need to perform. This num of 1 is the data we already know. This num of 2 is the data we already know. And k is the value we need to find out, right? What we could actually do is we can say the minimum value of k is equal to 1, right? That is, we need to perform at least one operation. If not possible in 1, we are going to perform 2 operations. If not possible in 2, we are going to perform 3 operations. So we could simply loop starting from 1 up to a certain point. That's the maximum value of k which is possible. We are going to loop from 1 to k, and we are going to find out that smallest value which can satisfy this particular condition. Now let me try to explain you with the example we have already discussed for 22 and 5. If the value is 22, that is num1 is 22, I could say this is 22 minus this is 2, right? We know the answer. Let's try to see can we actually solve the problem using this formula. So if we know the answer, which is 2, then multiplied by 5, because the value of num2 is 5. So this will be equal to 22 minus 10, this will be equal to 12. So we just need to prove that 12 will be equal to sum of 2 to the power a plus 2 to the power b. Basically, why 2 times? Because we have to perform operation 2 times. We could simply say 2 to the power 2 plus 2 to the power 3, this is 4 plus 8, this is 12, right? So this is how simple we can solve this if we know about this formula, and this formula is correct, right? Now let us try with a formula, or let us try with a data for which we cannot solve the problem, for which this particular value cannot be equal to 0. The example is when the value of num1 is equal to 5 and the value of num2 is equal to 2, right? Now let us try with different values. Let us say the value of k is equal to 1. We just perform one operation. Then this will be equal to 5 minus 1 multiplied by 2, which is equal to 3. Now can you represent the value of 3 in just one particular number, because we have to perform the operation 1 times, right? The value of k is 1. Can you represent the value of 3 in 2 to the power a? No, right? 3 cannot be a power of 2. So let us try with k equal to 2, right? So now this will be 5 minus 2 multiplied by 2. This will be equal to 4, right? So 5 minus 4 equal to 1. Can you represent the value of 1 into 2 of powers of 2? 2 to the power a plus 2 to the power b. Why 2 powers? Because we have performed the operation 2 times. We cannot do it, right? We cannot just represent the value of 1 in 2 different powers of 2 and their sum. I can say 2 to the power 0 is equal to 1. But the formula is 2 to the power a plus 2 to the power b, because we have performed the operation 2 times, and that should be equal to 1. Even if we keep the value of a and b the minimum, which is 0, then also this will be 1 plus 1, 2 to the power 0 plus 2 to the power 0, which is equal to 2 and not 1. And if we try with 3, then this will be 5 minus 3 multiplied by 2. This will be negative, right? Anytime this is negative, we are sure that we cannot turn this num1 into 0, because you cannot have this particular value equal to 0, right? 2 is to power a plus b plus how many times you take the power of 2 and take the sum, this will never be negative, right? So what we need to ensure that this particular data should be a sum of k, right? Not sum of k, but sum of 2 is to power of a plus 2 is to power b plus 2 is to power c k times. You can take this particular data k times. Sum of k different powers of 2. Now what we can simply do is, let us say if it is 22 and this is 5, again the same example we have already seen. So we can say, okay, let's keep the value of k equal to 1. If we keep the value of k equal to 1, then this will be 1 multiplied by 5. 22 minus 5 is 17. Can you represent the value of 17 in 2 is to power a? Only 1 2 is to power, because we have to perform the operation 1 times. No, we cannot. And how we can actually find it, I will tell you. See, the thing is, this is 12, right? The binary representation of 12 is 1 1 0 0. It has two number of ones. If you see any number which is a power of 2, let us say if it is 2 or 4 or let us say 16, all of these data are going to have just one number of set bit in its binary representation. 2 is 1 0, 4 is 1 0 0, 16 is 1 0 0 0 0, right? So from here what we can find out is a particular number, let us say 12, if its binary representation is 1 1 0 0, then we are sure that this requires at least two number of sum of powers of 2, because it has two number of ones, right? So if we talk about keeping this value as 1, and the value of num1 is 22 and num2 is 5, and the difference now is 1 multiplied by 5, which is 5. 22 minus 5 is 17. Can you represent the value of 17 in 2 is to power something just one times, just 1 2 is to power? So you can say, what's the binary representation of 17? It is 1 0 0 0 1. No, it needs at least two different numbers, so we cannot do it. Let's try with two operations. If we try with two operations, then the value of num1 is 22 minus 2 multiplied by 5. This will be equal to 12. The binary representation of 12 is 1 1 0 0. It needs two powers of 2, and we have two operations, right? We have kept the value of k equal to 2. So yes, we can do it, and we will return true, and the value will be 2k, or I would say the value will be 2. Now if the value is 5 and 2, in that case we are not going to get any answer, and we are going to return -1, because we are going to try with different particular value of k. It will be 1, then 2, then 3. When you try with 3, then this will be 3 multiplied by 2, which is 6. 5 minus 6 is -1. The moment it is negative, we can say, okay, we are not able to do it, because it will never be possible to make this 0. But before that, if you see, if the value of k is equal to 2, then this will be equal to 1, right? 5 minus 4. Can you represent 1 in two different powers of 2? Like as a sum of two different powers of 2? No, you cannot do it, right? The binary representation of 1 is 1. It just needs 1. We have to perform operation 2 times. Still we cannot do it. And that's the issue, right? So this is how we can solve the problem. And the solution is very simple to understand. Let me actually show you that. So I have already written the code. If I try to explain you the code, then you will notice that the value of k equal to 1. Let's start with the number of operation which is equal to 1. And now the new value of num1, or I would not say num1, but we are saying that this is our formula, right? If you remember, let me get back to the pad. This is our formula, num1 minus k multiplied by num of 2. So if you apply the same formula, say that this is our value, then the value x should be a power of 2, should be a sum of powers of 2, and the number of operation we perform is 1, right? So we are expecting that the binary representation of x will have a maximum of one number of ones, right? So what we can do is we can say, while the value of x, while this particular value is more than equal to 0, because anytime if it is negative, we are going to come out of the loop and we are going to say return -1. But till it is positive, we can find an answer, and we are saying that x equal to k equal to 1, then this is the value of x. If the binary representation of x, and count the value of ones in the binary representation of x, that is, here we are trying to count how many ones does this binary representation of x has. If that is less than equal to k, because k is the maximum number of operations we can perform, and this value k should also be less than equal to x, because see, the thing is, if this particular value, let us say, is 2, and the value of k is 1, it means we cannot perform the operation, because we are allowed to perform one number of operations and it needs two powers of 2 as a sum, right? But let us say the value of k equal to 3, and this particular value, it has two number of ones. This particular binary representation of x has two number of ones, but the value of x itself is, let us say, less than k. If x is less than k, it means that we need to represent the value of x in k powers of 2, k different powers of 2, but it just needs less number of powers of 2s, right? So in that case also we cannot perform this operation. So this particular condition is checking that our number, that is x, if we take the binary representation of x and count the number of ones in that, if that particular value is less than k, and if the value of k itself is less than x, then we can return k. Else, let us say that k plus equal to 1. That is, let us try with more number of operations and the value of x will get updated because the value of k got updated. So this is the complete code for this particular problem. Once you submit this, this is going to pass all the test cases and it is a very efficient solution. And the time complexity here is O of 1. The space complexity is also O of 1 because the value of k is constant, right? It will have a defined range. It will be like 30 to 40 to 50, but not more than that. So that is why we are performing this particular loop not more than 50 times. So that is why the time complexity is O of 1, space complexity is O of 1. And now guys, we have solved this particular problem. And that's it for this video, guys. If this video helps you to understand the problem and the solution approach as well, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.